Hi, everybody. I'm really excited to have the opportunity to talk to Dimitri, who is a good friend and also the CEO and founder of Silectis. So, Dimitri, welcome to join this conversation. I know you have a lot of background in working with companies to build, to deal with big data problems, basically, and maybe tell us a little bit more about your background because I think it's really interesting, and then how perhaps that has led you to create Silectis.
Sure. Thanks for inviting me today. I'm really excited to talk a little bit about the company and a little bit about my experience. So, my background, initially studied computer science in college, went on, spent some time both on the consulting side, a lot of it related to data management and data warehousing and building data solutions for customers, as well as some time on the business consulting side, and then also in product development and in software engineering. The problem that I've seen really for the last, 20 years or so has been the issue of just, how do we comprehensively manage data inside of an organization? How do we derive value from it? That's been a challenge, and there are best practices that have emerged. I think that there are a lot of folks out there that over time gotten to some very good solutions around it. But what I've seen over the last few years in particular is that there's been really an expansion in the number of options that are available to organizations. We've got the cloud now. We're able to store and manage more data. There's a sort of heavier stack of technology that sits on top of the raw data. There are more choices to be made. And really what that ends up driving is complexity. Data teams need to be smarter. They need to be they need to be broader in their technical expertise. And the expectations have been kind of ratcheted up by the business. And I really started the company to address that. I think with the cloud, what we see is a good deal more flexibility. There's a lot more that we can do. We can spin up solutions faster. We have less concern about scalability than we used to. But that added complexity, I think, is really hurting users. It's hurting by users, I mean, business organizations in general that are trying to get value from their data. If you look at the modern data stack, what you see is there's the underlying cloud infrastructure, and that includes, distributed object storage, things like S3 and Amazon, things like Google Cloud Storage or Azure Data Lake Storage. You've got compute that sits on top of that, and that could be anything from, something like Spark or Dask or these kind of distributed frameworks that people are using to more conventional database solutions. And then you've got all kinds of tooling that you really need to get value out of the data, like catalogs, data quality solutions, data lineage, putting all of those disparate pieces together and developing the knowledge within the team to be able to really capitalize on the cloud is incredibly challenging for most organizations, right? But typically mid-sized organizations, even if they have a very large IT team overall, it might be a handful of people that are dealing with these data issues, and expecting them to have expertise across that entire set of technology, I think is unrealistic in a lot of ways. So that really is what led me to start the company. I wanted to build something that was a comprehensive solution, something that reduced complexity, particularly from an integration perspective across tools, and allowed organizations to access, a leading edge stack without necessarily having to reskill or retool their entire team, and still had, kind of an underlying foundation built on open technology, so that people could capitalize on all of the great things that are happening in open source. So our platform, Magpie, that we've built at Silectis, it's built around Apache Spark, but it's got a layer of tooling that sits on top of it that actually makes it accessible to a broader swath of users, while still allowing you to dive in and integrate, all of those open source Python libraries that you like, or pull in things from the Scala ecosystem and still leverage them in a scalable and distributed way. So that's really the story there. It is about, how do we deliver solutions that work in this more complex context and make them accessible to a broader swath of organizations.
And when you talk about the companies that you work with, and we have this conversation, is these are still companies with billions of dollars of revenue and have significant amount of data they have to deal with. And maybe touch on that, and also, what do you see as the kind of the typical data data science team or generally the team that's working on, the data management problem. So maybe highlight that based on what you see.
Yeah, I mean, so I'll give a couple of examples without naming names among our current customers, but we've got several customers that are in that neighborhood of let's call it just shy of $1 billion a year in revenue to $2 or $3 billion a year in revenue, and that actually seems to be a kind of a sweet spot for us. When you look at the composition of the teams in these companies, even though they're awash in data, like terabytes of data and not tens of terabytes or hundreds of terabytes of data overall. They don't have large teams that are dedicated to data management and data management, particularly for analytics.
You mean like 100 people, 50 people?
I mean, it's really on the order of like 20 or 30 people in a lot of cases that are operating that piece, or they may just be building that capability because most organizations have grown up managing their operations and not necessarily thinking about how to bring more value out of their data or how to build data products. And so they've got a team of folks that are very capable, that are doing their best with the resources that they have, but they don't necessarily have an unlimited budget to go out and build a team of hundreds of data engineers, like you might see maybe in like a Fortune 50 environment. And in that context, you can't have people who are hyper specialized around, this person's very capable on the AWS stack and being able to deploy solutions out to AWS. And this other person is very, very deep on data modeling, and this other person is very deep on performance tuning. You really need people who are kind of trying to be a jack of all trades. And in that context, you need tools to make those people more productive and to make those people better. And this is against the backdrop of a really competitive labor market, right? Like it is very hard to hire people right now, particularly people that are skilled in this specific area. And so, tools to some extent are the answer to that.
And when you talk about tools, like, the tools that you deploy to a customer, like where do they start? What you talk about kind of what they have today, right? Which they probably have invested over the last maybe 10 years, the traditional data lakes and so forth. And they have data stores and more of traditional analytics. And they probably want to move on to more of automation, apply more machine learning and et cetera. So maybe walk us through that kind of the modern data stack, because that word has been used many times across industry. What does that mean to you and your customers?
Yeah, so for my customers, typically what we've seen, and this isn't universally the case, but it's quite often the case. They're, depending on the age of the company, they have a traditional data warehouse, and that means, ETL tool, call it, Informatica or Talend or something like that. Feeding a relational database and with a dimensional model that is being used for BI essentially. And that's a fairly rigid model. It's difficult to make changes, it's difficult to add new data, it's difficult to then deliver that data to users very quickly. When you think about a more modern data stack, I think the starting point is capitalizing on the cloud and the inherent kind of flexibility of the cloud. So what does that mean? You have cheap, redundant, kind of fast enough storage. And typically that's something like in AWS, the S3 service, for example, you're getting, you're not having to worry about backing up the data. You're not having to worry about, file layouts like you used to with Oracle configuration or something. You've got that baseline stack of storage, again, cheap, redundant, able to be accessed in parallel. Sitting on top of that, you have some kind of a compute layer. And that compute layer in the modern data stack is taking on a lot of different forms. You've got, again, Spark, which is a great sort of general purpose distributed framework that supports a lot of different kinds of workloads. You've got even something like Snowflake that sort of, from the user perspective, looks more or less like a traditional database, but has done a really good job of decoupling the compute from the underlying storage. That difference from traditional systems is incredibly powerful in terms of changing the way that people think about data management. You're not having to lockstep scale your compute with your storage. Your storage can be cheap. You don't have to worry as much about archiving data or the size of data. Your compute, you can turn up and down whenever you need it, right? Those are kind of the core elements. And those two things taken together are really just change the economics of data management and give you a lot more flexibility and allow you to operate on larger data sets. You go one layer up from there and you start thinking about, well, there's access. So, from a BI perspective or from a data analysis perspective, how do I actually get at the data?
Right.
And, for business users, that might mean a BI tool of some kind that's allowing you to do data visualization. It might mean, some kind of a set of data science tooling or libraries that allow you to build and execute models. It's, a very kind of, what are all the things that you can kind of point at it? And what are the different kinds of things that it can support? Again, when you look at that versus traditional stack, it's really hard to run data science, to train a model on a traditional, on-premise relational database, because it's just not performance tuned for that. Whereas in the cloud, you can do that. And then you start thinking about, okay, well, what other tooling do I need? Well, you need a catalog because you need to be able to know where to find the data.
A data catalog, right?
Yeah, a data catalog, essentially, that'll tell you, here's where this data resides.
Yeah.
Who should have access to it? How can I take that, that file that's just sitting out there in something like S3 and turn it into something that can be queried interactively? And again, it's, kind of plugging that into whatever your computing framework is can be kind of like non-trivial, right? And there are a lot of different solutions for that. There are standalone catalog vendors, vendors like us, we have catalog kind of built into the product itself. And there are, other kind of more integrated solutions. Beyond that, you need, some kind of security and governance layer so that you can set rules and policy about who has access to which data. You need auditability around that. So who's been accessing the data? You need tooling that allows you to ingest and transform the data to get it into a form that's more usable by those folks like data scientists and business users who are trying to get value out of it. So, there's a whole slew of different things that you might want. There are a lot of ways to get there. The big cloud infrastructure as a service vendors have their answers to that. So inside of Amazon, you can say, hey, I'm going to use S3 for storage. I'm going to put Athena on top of that. I'm going to use the Glue catalog as my catalog. I'm going to use Glue as my, essentially as my ETL layer. And now I've got something, right? Well,
there's nothing wrong with that, but it assumes that that company is, they're committing to build everything on one particular infrastructure end to end. And they need to find specialists and talent who knows each of those pieces.
That's right. That's right. And then, you've got to deal with sort of the warts, right? There are things about that set of choices that isn't right for everyone. Similarly, you might grab some open source tools that allow you to do the same thing. Like you can still deploy your own Spark stack, either through the EMR service or by actually, building your own images inside of AWS, right? And you can decide to go that direction. So there's just a huge number of choices that folks can make.
Yeah.
And that's where I think a lot of the complexity comes from. I've seen organizations really be, kind of paralyzed by just doing technology evaluation across all of these different solutions. There are a few collections of things that are emerging that are gaining some traction, but as with everything else, it's this is a fast moving environment. There's some risk and there's lock-in risk, and then there's just pure technology risk. Some of these things don't work as well as they might advertise.
Yeah, well, one of the things I think assumption I think is being proving out is that if you're a data scientist or even data architect or data analyst, that profession is evolving. That professions are evolving, and they have to know if they want to be true, extremely effective in the organization. They need to know about something about catalog, right? They need to know something about data lineage. They need to know something about governance. They need to know something about auditability. So the role is less siloed, and especially as you kind of get into the kind of the clients that you have, the job kind of demand that they are able to have some knowledge and be able to have enabling tools to allow them to work end to end, because that's just better for the organization. I mean, do you see that? I mean, that's at least my hypothesis.
Yeah, it's an interesting problem, right? And it gets to kind of role definition.
Yeah.
For data engineers, um, these roles they're demanding a lot of breadth. It really is like, hey, we would like for you to understand all of these different moving parts. Folks need to know a little about a lot of different things,
Yeah.
and then they need to be able to kind of go deep in one or two areas. Again, I think that speaks to, how this impacts organizations at different scales. For very large organizations, you can have kind of this hyper specialization where people can be, even if you're a data engineer in one of those large organizations, it pays to be broad and know about all of the different components of the life cycle. But you can specialize, and it's easier to get deep, and it's easier to operate in an environment where maybe there are more tools and more moving parts. As you start to get to smaller scale organizations, it still pays to be broad, but now you're sort of getting into a situation where it can be very difficult to make forward progress if you're trying to get deep on all of these different pieces because you're not staffed right to support all of them. So it's a little bit of a trap in some sense, right? Like I think breadth and good foundational knowledge pay for anyone who's trying to develop themselves professionally. But the problem I think that a lot of people run into, particularly at mid-sized or smaller organizations, is that they try to know everything about everything and end up in a situation where all they're doing is dealing with technical debt or dealing with technology issues or disconnects.
Yeah. So
Does that
let's
make
talk about that makes sense. So let's talk about like Magpie. So is that multi-cloud, and where do your customers start? Like what's the typical first component they use, or like the second components, and then how do you kind of get them to be where they want to be, right? With a small team and still be able to do everything that you just talked about.
Yeah, I mean, it's everyone has sort of a different starting point. I think a typical use case for us is, hey, we've got this data, we're in the cloud, we don't feel like we're capitalizing on it the way that we need to. And it might be that they've got a data lake, but that data lake is, let's say, a little bit messy. Or they've got some big data transition that they're making that they need to facilitate, right? We're migrating from this, SaaS platform to this other SaaS platform.
And they want to harvest more insight from the data.
Exactly. And, that's sort of the setup. And in terms of how do they get going with our platform, the thing that we like to do is we like to get folks up and running very, very quickly, on the order of, days or weeks, with an instance in our cloud that is reading data in their environment. Typically, all it takes is setting some policies on an S3 bucket to give your Magpie cluster access to your data storage. And we're immediately able to kind of harvest the schema of all of those data files that are sitting there, start to build up some profiles that allow you to get very rapid insight into what the data content is. And from there, you can start pretty quickly, prototyping, hey, how do I need to transform this data? What's the set of transformations I want to apply? And then working from there, you can start building your pipelines. You can start giving analysts access to some portion of that data, because now there's a secure way for them to get at it. And it's not like, hey, here's an AWS identity, go ahead and look in this bucket, right? Here's an organized interface. Here are some things that look and feel a lot like database tables. And here are some tools that allow you to kind of accelerate your understanding of that data and allow you to build some derived objects out of it. And that really tends to be the starting point. I think where customers have been really pleased with the platform, it's that ability to feel safe in the sense that, hey, there's organization and governance around what we're looking at here, but also get going fast. And I think that's been really powerful. So, it's when there's some urgency around it, or when folks have failed with other solutions, that tends to be a really winning environment for us, because people, kind of have known the pain, and they understand how valuable it is to be able to very quickly get insight into your data and have something that feels like a complete solution.
So that's kind of the first piece. And then where do they graduate to?
Yeah, where do they graduate to? I think what we see when customers get more sophisticated is they start there are a couple of things, right? One is they start thinking about, okay, well, now how can I add value to this data? I've built some kind of a hub for my enterprise, and you can call it a lake, or you can call it or you can call it a warehouse. What else can I do? What is the product data that I haven't been able to see before? How can I integrate that now? And so then it's kind of add more, start to build out production pipelines that are refreshing that data on some continuous basis and potentially delivering it into a platform like Snowflake, for example. And then getting beyond that, it's, hey, look, there is this richer set of capability that we have available through, for example, all of the open source ecosystem that exists around Spark.
Right.
If they want to, a lot of, some of our more sophisticated customers, particularly on the data science side, they'll dive in and they'll start using PySpark. But what they're doing now is they're not operating on, hey, let me, pop up this file and do something with it. It's like, hey, here's a ready set of data that I can use. We've got an API that we expose in Python that allows people to get access to all of those value-added things that we do in our metadata, which includes things like the lineage of the data, the profile information, and all of that. So there's a lot of very intelligent things you can end up doing with the data. I think when I think about for our most sophisticated customers, it's really, it's not that they start doing something drastically different than what they've been doing before, as much as they're able to accelerate. So it's, what's our time to value for some new piece of data? It's no longer 6 to 8 weeks while we figure out how to push it all the way through Informatica and into Redshift. It's, hey, what can we do if we get a dump of data from this file, take a look at it, do a little bit of refinement, and expose it to the people that need it as quickly as possible. And that's, it's shortcutting that timeline. It's making the iterative loop between the data engineering folks and the analysts and scientists a lot quicker.
Yeah.
And so all of that collaboration is a lot smoother and maybe a little bit more tightly knit. So I think that's where the benefits have come, particularly for our more mature customers that have been in the platform for a couple of years. It's that collaboration across teams that I think has been really powerful.
Just a quick follow-up question on that is, as you kind of think about your customers, were there any things that were in Magpie and, they just surprised to have, like they didn't know they needed, but then I was like, wow, I actually need this. This is so cool.
Yeah. There's there have been a couple of ahas like that. I think a lot of folks who haven't used data profiling before are really.
What is data profiling? If you could
So data profiling, it's essentially kind of cracking open a particular table and saying, okay, well, how can I rapidly and in an automated way summarize the contents of the data? So, if I've got some, in one of our demos, we use this New York City taxi cab data set that I'm sure a lot of people have heard of. And it's, it's like trip distance, for example, is a numerical variable. We'll automatically build a histogram of the distribution of trip distances. And, you look at that and you very quickly get an idea of the fact that most New York City taxi cab rides are less than a mile. And there's a long tail of, people going even further out, but, it's really concentrated around that 1 mile mark. It's looking at date fields and automatically laying those out on the calendar. So you can actually see what the frequency is by time of year. So you can very quickly look at a snapshot of some set of records and see seasonality. And so that's really what our profiling delivers. And because we're built on top of a scalable framework, and because we've made some smart choices about how we tune that process, we're able to do it very quickly over large data sets.
So that's one that they didn't know they wanted or need to have.
Yeah, that's one that they didn't know they wanted, or that wasn't sort of an important part of it, but very quickly became important. I think lineage is another one that people, again, it's like no one was really talking about lineage a few years ago. And so, it's like when people see data lineage, it's like, oh, I've now got a window into what I've done with this data. And that helps in a few different ways. There's kind of a diagnostic aspect to that, like how has this data been transformed and how did it get into its current state? But there's also a really high, it's really high value in being able to retrace your steps and say, okay, well, this is something that I think is valuable that I want to reproduce. And now I've got this running log and I don't have to be necessarily as thoughtful while I'm in that process of kind of like improvising with the data, because I can always go back and look at the lineage and generate a pipeline out of that.
That's really cool. We have like 1 minute, Dimitri. So, there seeking a short answer on this, maybe not too short, but there's a lot of debate in the industry about kind of who will be dominating the big data management space, and what are some of the mega trends and how people will gravitate toward or use these tools. And there's been waves, right? There was like the business intelligence wave, the predictive analytics, and then you have the data stores and data lakes. And where do you see things going? Because you've been in this industry for a long time and expert in this as well.
Yeah, I mean, I think I'm going to make the very safe prediction, which is, we're still at the beginning in a lot of ways. I think there are some stats around the percentage of the overall workload that's actually migrated to the cloud thus far, and it's a relatively small percentage. I think it's something less than 10% of total compute that's moved out into the cloud thus far. I think that there are some great lessons that we've all collectively learned over the course of the last, let's call it 7 or 8 years in particular, that have to do with separating compute from storage.
Yeah.
They have to do with flexibility and sort of resilience to different workloads. They have to do with how and when schemas get applied, and what kind of intelligence you need in products. I think that some of that stuff is durable. I think some great companies that have emerged that are going to go the distance are out there, but I also don't think that we're living in a space where, hey, we're now it's going to be consolidation. I don't think we're there yet. In particular, I think that generally the data access and compute part of it needs to become increasingly sort of effortless. And to some extent that has to do with like abstracting away some of the underlying compute infrastructure. So not necessarily, being able to use something like Spark without actually thinking a lot about Spark, I think is really important. Not having to think much about configuration, not having to think much about, oh, well, I'd better partition on this key if I want the performance to be good. I think there's a huge opportunity there, and that's something that we're working on. I also think there's a huge opportunity to some extent abstract away from what the underlying runtime is and just provide a common sort of smart way of accessing data and marshaling data for analytics that's a little bit less tightly coupled to whatever the underlying mechanism is. So I mean, I think those are kind of vague answers, and I think it's a little, I'm a little gun shy about making predictions, other than to say I don't think this industry is settled yet. I think that there's still a lot of fragmentation. I think that there's still a lot of room for innovation, and I think that we should expect more of ourselves collectively in terms of like the kind of experience we're creating for users, and the kind of organizations that we serve. I think it's very easy to try to solve the biggest, hardest problems that only the biggest organizations have, but the vast majority of folks are dealing with smaller scale problems that don't lack any of the complexity, and building tools for those people, I think, is really important. And that's something that we're focused around as well.
Yeah. And if you think about, every organization is a data company in many ways, right? And I agree with a lot of the things you said and the opportunity ahead. Dimitri, thank you so much for sharing your perspective, and big fan of what you're building, and look forward to see more of Silectis, and thanks for joining this conversation.
Thank you. It was very, very enjoyable to just kind of